Hi everybody, thanks for coming. Just walking around, looking around. Everybody speaking German, and I could switch to German, otherwise I'll just keep it international so everybody can follow. I'll keep it. Thanks for coming, you especially. Hi, my name is Fabian. I'm from the immersive agency Headraft, and I'm going to be talking about Tunnel AR. It's a music video that we did in augmented reality at the beginning of the year for the Fantastischen Vier. Most of you probably know them. So this talk will have some sort of a technical side, and there will be a lot of content about what actually was necessary to pull this off in total, because AR is such a new medium that just the acquisition of the project itself and everything around that was kind of interesting. So I'll give a broad overview, and we'll dive into some technical stuff towards the end then. For those of you who don't know what that actually was, I'll just go ahead and show a little video that summarizes everything a little bit, and then I'll dive deeper.
If you've been Germany's most popular hip-hop band for 30 years, a new song release needs to be spectacular. So, Die Fantastischen Vier released their new single Tunnel as a literally groundbreaking augmented reality music video.
Siehste, das hast du davon. Krise, hast du bekommen. Düster, ist alles geworden. Nur Wüste, aus Stahl und Beton. Ach, was?
In the free app, you take over mission control. While you drill a tunnel together with the band, you can interact with spectacular worlds that are right in front of you, before finally blasting into space. But before you could join them, the artists had to enter the augmented reality themselves. Their faces were modeled in clay, and we later digitized them to get a handmade look. To really bring them to life, we also developed a motion capture app to record the band's performances with the help of Face ID technology. We then dug into the band's 30-year history to design the tunnel from real-life materials, such as their first instruments, awards, and other objects that shaped their career. Fans and the media celebrated the app, sending it to number 3 in the German App Store, resulting in over 40,000 downloads in Germany in the first days. But we didn't stop there. After the release, we delivered an out-of-this-world music video created with the Tunnel AR app.
So this is what the entry site looked like. Of course, in the beginning, it was more like that. The whole project was super short in time, typical for the music industry. They want everything perfect in no time right now, and the launch date is set. So first we had to figure out what the hell do we even do here. The Fantastischen Vier, they're usually quite progressive in what they do. They always try to capture new technologies and see what they can do with that. And so they were just like, hey, let's do something new. There's this thing called VR. Can we do something? And VR was obviously not really the right fit for it, because there's just no user base for it. So in the beginning of November, we started talking with the director, and we just knew we had to present them something sometime in December, and the launch will be on the 23rd of February. So that was basically the timeline without really knowing what it was going to be. So the main takeaway was, let's do prototypes and make sure we know what it's going to be after about a week. Otherwise, it's just not going to happen at all, just squeezing that production in such a short amount of time. So we just sat together in a small team and tried to assemble ideas that would allow us to deliver on such a short timeline. The director of the project, he has a very strong style in stop motion graphics and that sort of thing. And from the get-go, it was quite obvious that we will go in that direction as well, because that way we can also produce assets really fast. The whole tunnel is super big, and there's tons of assets in there, and just producing them in such a short amount of time was not going to happen if they were to be done manually. So we got into that style, and I dive into more detail how we did it in just a bit. So that was one thing. Let's make it quick and dirty, and still make it look good, and find a balance between how do we make it as awesome as, of course, everybody expect there. I mean, it's Sony behind as a label. The Fantastischen Vier is not quite the smallest band as well, and something that's just okay wouldn't be good enough for them. But technology just isn't there. At that time, when we started talking, ARKit was just released by Apple, so we had access to that before in the beta program, but it was just new in the phones for a couple of weeks. So nobody really knew where the performance limits and everything really were. So finding a balance between technology and style was a huge challenge, as well as usability, because nobody knows how to use AR on the consumer side in the end. So it had to be simple enough, but still have enough punch to be interesting enough. What we came up with was the design of the tunnel. I mean, the song is about digging a tunnel, so why not dig a tunnel? Where you would see a tunnel emerge from the floor, from the table, from anywhere, and just go through tons of different worlds. Tons, well, 6, still a lot for 10 weeks of time. And you still need to see it from every angle. So if I start here and place a tunnel over there, I will need to be able to hand the phone over to somebody on the other side, and he will still have to see everything and not be blocked by the view of the tunnel. So what we came up with was this design where we just take slices and hide the slices when you walk around. So you see, I think there's a video playing. Yeah. So you can see in the second prototype, more or less, super crude. It just pops in and out. But wherever you look, you will always see everything. So we also had to make sure, of course, to put all the content on both sides, so that you will see anything that you have to see, no matter where you are. But the view can't get blocked for you. So that was like the main design element that we used, and it worked quite well. Of course, a lot of this had to be planned in advance. So all of these worlds were just mapped out. Every one of the 4 artists has his own world, so 4 for the artists, and we had space. And the surface world. So it starts on the surface, and you start digging through 4 worlds, and in space, and then a loop closes. So we needed to establish a couple of different styles and make like a building plan that you see on the right. How many assets and what they need to contain do we need to just assemble everything before we even start to work on that. Of course, this was just the start. This was like a complete merchandise music video launch. It was the new single of their new album, and they haven't released for a couple of years. So there was a lot of work before that, just teasing everything. So a lot of asset production and concept design went into that as well. So you could launch in January without even having the app yet, with just images from the app and some content, some teasers, because nobody was supposed to know it until it actually hit the market on 1st of March, I think. The faces, of course, you had to kind of grasp what that should be. So we modeled them in clay, give them a bit of a stylized look. So this whole drill head is basically all the 4 heads assembled together in a look that will fit the environment and still look sort of real. And what you see on the right side there is the prototype that we then showed the client. So we went to Stuttgart and met with the 4 plus their management, and that's what they saw. Before that, we just talked. And they were, of course, like, okay, that sounds super interesting, but what is it? So we gave them a phone, and they had it in their own hands, and that was the tipping point. At that time, we've been in the production for probably, we've been talking about it for maybe like 2 or 3 weeks, and working on this for 2 or 3 days or something, and just making it work, seeing the whole thing synchronized to the music, so that they would have like a super, super rough experience of what will be there 2 months later. And that was absolutely crucial and necessary. Without it, it just wouldn't have happened. This is such a new thing that nobody signs off on anything without seeing it first. So this was really, really important, and it's been like this for any other project, more or less, that we do in AR. Once you see it, once you can feel it in your own hands, then it works. The same goes for VR there. But this was super crucial. These are just some images of the head designs. Of course, there was like tons of iterations on that, because this is the centerpiece, it has to work. Same for the drill head in itself. This was just all painted. And then later just modeling clay, which was just the fastest way to do it. Because that was super crucial. Modeling this in CG would have taken longer, because we had a good production department, and they just punched them out like nothing after we had solid concepts. So we started mid-December. There was this usual Christmas break, and of course there still had to be a shoot for the music video and for the motion capture of the faces. It's a bit hard to see in the video before, but when you go close to those faces, they are like lip sync to the song. So their whole performance, their head movement, their whole facial mimics, everything of that is in there. So we had to capture it somehow. And when we launch in March and shoot start in December, there has to be a shoot somewhere in between. So that was mid-January. So right after the Christmas break, and of course. Traditional mocap was just too expensive and too much of a hassle. So at that time, the iPhone X was launched. And the iPhone X has this little feature called Face ID, which does a pretty good job of scanning your face. And so what we did is we basically took that and made a live motion capture with the iPhone. So instead of building a super expensive rig that was just cost more than the whole production, we bought one iPhone X and coded an app in like a weekend over Christmas that would just record raw data of that. Because what this iPhone Face ID gives you is basically 51 blend shapes. This is like eyebrow up, eyebrow down, cheek, chin, everything in 0 to 1 values, and tells you, is it open, is it closed, where is it? And it gives me a transformation matrix of the head. So I know where it is, and I know where it's looking at. And what we did is just record all of that, 60 frames per second, down to a JSON file on disk, as it's just like about 3 or 4 minutes of recordings, a couple of seconds of pre-roll, then they perform. It's pretty lightweight still. I mean, it's super. Let's not talk about optimization there. One take was like 50 megabytes or something. It's stupid, but it just works for that. And we just record a bit of a timestamp so we know that we are not drifting too much and can correct later and get a stupid-ass JSON. And then later just take that once we actually establish the whole asset pipeline on the 3D side of things, and wrote a little Python script that would compile it to an animation file that Maya, in this case, could read. So we then just dropped that file into Maya, and we had animations going. And there was very little cleanup. As the screen is so small, it was just about enough to not clean up all the subtleties in the face. We only need to clean up the larger head movement, mainly because we had to keep them constrained to the drill head by itself, because of course they were like moving around crazy and like going like completely out of control, and that of course wouldn't work there. So there was about 1 day of cleanup for all 4 of them. So it's 4 times 4 minutes of performance captured in, I think, half an hour on set for all 4 together, because I think only Michi did 2 takes. Everybody else just took 1 take, and that was it. So it took literally just half an hour and 1 day of cleanup, and the whole 16 minutes of animation was done. And that was, of course, crucial to just make it in the time. The other big challenge was the tunnel itself. 4 phases, that's one thing. About 160-ish meters of tunnel, that's a bit of a different challenge. We had the surface world in the beginning, where you start out, there's lots of robots roaming around and a bit of just onboarding the user for I think 30-something seconds. And so there's a little countdown timer telling you when it will start off. After that, we dive down into the music world. Every world is coined to one of the artists, so music world is for Andy. After the music world, it just goes into a bit of a grittier, glowing, cold, darkness thing. After that, smoother is up with the luxury gold world. The brief there was literally take Trump Tower and compress it. So everything in there is gold, and of course this Trump reference, we like that. So you can have gold bars, decapitate Trump in there. The Fantastischen Vier are quite political as well, so there's lots of little references to that sort of stuff hidden in there. And there's a future that when you find all these little Easter eggs, every world has one, so you can interact with the drill head and make it overheat when you spin it too fast and everything, and find Trump. And when you find all of them, you collect those little patches on the right side, and then you get a remix in the end. So there's just a little tiny reward, but a little bit of gamification just helps keep the users engaged. After Smoothers world, then there's the future world, which is just pipes and greenish, and the mood completely changes all of a sudden. Then it just takes off ridiculously. So we start boosters on that thing and rush it through just metal and blast the whole head into space. Up until this point, everything was on the table or on the floor. So you had a little camera view and CG content augmented on top of that. Once we reach space, the camera view is gone. So it completely transforms into a full 360-degree experience where we don't connect it anymore to the real world. Of course, this gives a lot of freedom as well, and delivering a bit of a space feeling became possible by not using the camera track accurately anymore. So we just introduced a delay of, I think, about 10 frames that we averaged. So the last 1/6 of a second was just mingled together, and when you move the camera, it gets floaty. As it's not connected to the world anymore, nobody really notices it, but everything is a bit slower. And behind you, there's stuff happening, and you can just walk around and explore a bit and turn on those TVs and turn them off again. And there's old music videos playing, just like little GIF samples of them. So there's lots of explore in a whole nother dimension again, because it's not locked to the table anymore. The interesting thing was, though, in the beginning, I didn't tell you, the brief was we have to make it a loop. So once we're at the end, it has to start over seamlessly. So of course there needed to be a transition again from the space world back to the surface world, as they wanted to just see the video over and over again. So you start flying through like asteroids and all that sort of stuff, and end up on a planet, which is just a little chupa chup. End up on a planet where you just land at the surface that you've seen before, and it just starts over. That seemed like a nice concept in the beginning. It actually took a couple of days to fine-tune it. It was worth it, but it was a big struggle that I would have loved if it wasn't there. Because this was a big challenge as well. This is just a super tiny subset of the assets that we use to build that tunnel system. And there have been about almost 100 assets that were built for real, and then we scanned them. So this is maybe like 20 of them. Also the effects, everything was just built and then scanned, as you can see in the lower right corner. just to keep the coherent look. Doing like a normal particle simulation that you would do in such a case wouldn't look right. So we had stop motion artists do stop motion particle effects for us, which worked out really well. But that, of course, was a huge hassle. The workflow was building it for real, then scanning it, decimating the polygons down to of course, an amount that can be handled by mobile hardware, which I'll talk about in a bit. But doing that by hand was just too cumbersome, so automated decimation, then some cleanup that was strictly necessary, bake the textures on it, done. So we could do an asset within a couple of hours instead of days, as we had to do about 100 of them. Of course, this took about 50,000 photos and quite some space on the server, which was a bit of a technical challenge, but we just had tiny little pipeline script that would take care of most of the grunt work, and one artist actually could pull it off completely. So we had one guy for the faces, for some little parts there, and another guy for the whole tunnel, and that was it. As of course, budget was low, time was low. So this was the solution there. Of course, with such a workflow, this is not real-time optimized geometry. We were afraid of running into performance issues. We had to support iPhone 6s up until 10, and a 6s, that's kind of an old phone. It's not really that strong. And we were heading towards like 100K triangles on screen at any time for 4 minutes straight. So that was interesting. Fortunately, triangle count by itself isn't really that much of a problem nowadays, even not on an iPhone 6s. The amount of geometry is, though, like the amount of different objects and different shaders and different materials and textures, just filling up memory at some point, and just moving around that many objects proved to be a bit of an issue. So what we did there, on low-end devices like the 6s, we were completely CPU bound. The graphics were just fine. We were well below the limits, but the CPU just wasn't able to handle 4 times 20-something blend shapes per phase plus movement of a couple of hundred objects. So to make that a bit better, as of course we couldn't save on the faces, we static batched a lot of the geometry together in the tunnel. So anything that doesn't move in itself is just one object. We couldn't build it like that, of course, but had scripts running over it that would find those pieces and just make them one. So you just have one transform to move anymore and not 100. And that made it possible to get rid of the CPU-bound problem on lower-end devices. On higher-end devices, like especially the iPhone 10, we had the issue that it has such a high-resolution screen that the CPU, of course, was like more or less idling at that point, but the GPU couldn't handle it anymore, as it's a well over 2K, 60 FPS. That's not an easy feat. Fortunately, the screen is high resolution but still small, so we just wouldn't render full resolution and nobody would see it. So on the iPhone 10 in particular, we just rendered 2/3 of the resolution, and that just gave the edges a little bit of less crispness, but that was fine. Nobody really cared. It just looked more real anyways, because the camera feed itself is super noisy anyways. And if you have super clean CG on it, it just doesn't look right. So the iPhone 10 is easily able to handle it, of course, while the iPhone 6 and especially 6 Plus and 7 Plus with larger screens and screen resolution, they are struggling heavily on the CPU and just about on the edge on the GPU. So this was quite a challenge to keep it balanced there. And we did some tests with shadows in the beginning, because of course shadows would have looked great in there, but it was just not possible because of one main reason. It's 60 FPS, so you basically have 16.6 milliseconds per frame that you could use. If we did that, the phone would heat up within like at least 1-2 minutes. Doesn't really take longer, but it has to stay alive for at least 4 minutes. So we couldn't push that limit. So beginning we thought let's do 16 milliseconds, fine. In the end, we had to aim for 13 or 14 because that would reduce the temperature so much more that the phone wouldn't throttle, because iPhones terminal throttle really quickly, and that didn't happen anymore once you just hit 14, not 15 or 16. And for that, we had to do some custom post-processing because, like normal, this was all Unity on the engine side. Normal post-processing there is just too expensive, but we still needed things like animated color corrections to switch between those worlds seamlessly, as all of them have like super different visual styles. So there was some custom color correctors in there, just the cheapest way to do it. Nothing fancy, just remove all the fancy things from the standard stuff and just go with that. Standard grain, just too pricey. So what we did there is just take an image and take another image, and they look like grain, and we switch them. And that's fine. And that's like half a millisecond faster than a normal one, and that half a millisecond really counts a lot in this case. Chromatic aberration, just a cheap one, super subtle, works fine. And then, of course, we actually wanted bloom, and it was working. And it was working on almost all phones, just not the lower-end ones. But then we tested, and we tested, and we tested, and eventually the iPhone X was overheating. So even the high-end phones wouldn't be able to handle it in real time, just due to the heat problem. And the screen would dim, tracking would be super jiggery, and it would feel totally wrong. So that had to go, unfortunately. Of course, the look of that couldn't go. So the good old fakes came back in, and we just painted glow on certain textures and overlaid them in certain places where we needed them without any compromise. And that renders still a bit faster than actual bloom. It, of course, doesn't look as nice, but it keeps us at 40 milliseconds. And of course, this launch was in March. So temperatures start rising. And when the room was hot, 14 were okay. When the room was cold, 15 to 16 milliseconds would be okay, but we wouldn't know, and there was just no option. So thermals were the biggest problem in this case. But just disabling anything that wasn't really necessary and tweaking a few of the good things got us there. Talking about tweaking, as you maybe saw earlier, the tunnel is clipped at the top, so it only grows out of the floor for about 1 meter in size, and then it just vanishes. Usually you would just write this in the shader and have it clip at the top. Works well enough, but not within 16 milliseconds, not with that much content. So we squeezed out a bit of performance by not actually fading the shader at all. Instead, we had a shader that would, on the fragment level, just make everything black. That's what the top. And the vertex shader would just compress everything that's coming up. So we had segments that were like, if the whole tunnel is like 1 meter high, it would roughly be split into 3 vertical segments. And each of these segments would just be crushed. All the vertices would just be leveled on one plane and then faded black there. And once everything of that segment is there, we just hide it immediately. As it's just on a perfect plane, you can't see the plopping. And we gain a lot of performance by not doing any proper fading in the shader. So it can still be completely opaque shading without looking like it. And that saved a lot because we needed the alpha fade anyways for the whole segment thing that I showed in the beginning. When you move around, the segments plop in and out. Of course, this was too jarring. That just didn't look good. So whenever that happened, there is a proper alpha fade going on. And that ate away all the performance that we had left. So the base shader for all the geometry, because everything had to go through the shader, needed to be a bit more clever there, and that helped a lot. One little extra feature that we added that you can see on the lower right side is a glow. This is just super simple mapping colors to temperature. Nothing fancy there. We had ambient occlusion maps baked anyways that we would use for the shading, and those maps would simulate the temperature in there, so we could dynamically make objects glow, as for example the drill head that you can see there. The Easter egg in this moment is that when you swipe really fast, it starts spinning faster and faster and faster until it like overheats. So there needs to be a dynamic glow on that's connected to the actions of the user. And this way, this was coming at almost no additional performance cost, which helped a lot. Then there, of course, was this little challenge of animation. It starts playing down here. There were tons of objects. Of course, we animated them in proper animation software, and that worked out rather well. And on top of those, we layered user interactions. You could spin the heads, for example, and then it would always orient the singing head towards the user direction. So when you move around and another person starts singing, it will overlay that offset rotation, so you would always see the proper person and not just any random one, which was quite interesting. I'll just let this play for another couple of seconds so you can see like we're almost in space now. It starts speeding up and just scale objects in and out, because of course the world is really big, but we can't make it that big, so we faked that by scaling things up to make them appear farther away than they are, so we don't run into clipping plane issues with the cameras and all that sort of stuff. And on top of that, just a couple of procedural animation things. But this was just one mode. This was the main mode. Of course, the label wanted something they could share. The usual, oh, let's make the user make them share something, which is a good idea because it actually worked quite well. But we had to come up with something that would actually work. So on the top, there was this mode that I just talked about, and then we also had this destruction mode. So the idea there was that you could just walk up to anything and drill the drill head into whatever it is. So this was actually the pitch paper that was sent to them, and they loved it immediately. This did come with a couple of extra challenges, though. Here's the very first test of it. This is the director just playing. Usually AR tracking is locked to planes. A head is not a plane. So detecting where we are and what we want to do was a bit of an issue there, because detecting a plane takes a long time, and we are usually not drilling into other planes. So what we did there is just completely ignore what ARKit was supposed to do. When ARKit starts, it immediately goes into like a 3DOF tracking. So you get rotational values of your phone. That is good enough to place something somewhere. So we just placed the drill head right in front of the phone, and you could pretend to place it. After roughly about 2 seconds, it starts collecting point clouds in your environment, and that gives it some sort of a limited tracking state where you would start getting into 6DOF tracking. So you could move, and it would stay at the same position. And at that point, we just stopped, because we did have some spatial information. We know this is a point somewhere 3.5 meters in front of you, and we can raycast to that point or close to that point, so we would be able to find a surface like a face. In order for the user not to notice this, we use something called forced perspective. Maybe you've heard of that. So the object is in front of the camera at the same size. And once we know where it will be placed, we project it to that position and scale it inversely. So it doesn't appear to change at all for the user, but we can shift it in depth wherever we want. And this helped a lot because we could allow the user from the first second on to start drilling. But if you would get in a better tracking state while the user is doing it, we could still project it there without changing the video at all. So you could start like after half a second or after 2 seconds, and the user wouldn't really see much of difference. The concept by itself sounds great. Of course, it doesn't work that well. It worked well enough, so this was the solution in the end. The other big problem, of course, was recording the screen while doing AR, while doing complex geometry. There's a bit of a performance hit there, so the scenery had to be super, super simple. And recording a screen on iOS is not that great either. Due to time reasons, we just went to Replay Kit 2, which is a bit annoying because it asks the user for permissions every once in a while. So even if you allowed the app to record the screen after 15 minutes, it will ask again. Unfortunately, this couldn't be overcome due to time restrictions because recording on Metal inside of a game engine, possible but cumbersome and just not happening within like about 2 days that we had for that feature. So this could have been nicer, but it worked quite well in the end, and the user had like 7-8 second clips that they could share, and they did that, and they could win like little mission patches that were actually stitched on like on tissue and everything, and that was fine, and everybody loved it, and it was actually used quite a bit. And misusing ARKit in that way was an interesting challenge to see how and where you can push it beyond what it's supposed to be doing. And it worked reasonably well, and afterwards I talked to a guy from Apple, and he was like, yeah, we didn't think you could do that, but well done, and we're fine with it. So we got a bit lucky there. But that was good fun. And of course, so there's just these little points. Those are the point clouds that we see, and that we can project onto. And it's locked in space even without ever finding a plane. Just a little example. And of course, we had some fun while testing with that. It's a bit cruel, but it gets the point across. One last little feature was that they also wanted links to their stores for merchandise and tickets and for the album. And we really didn't want to clutter the UI anymore. AR mostly works well when there's not much or no UI at all, like HUD UI just locked on the screen. So we experimented with incorporating buttons into the AR experience itself. So there have been these 3 hotspots on the surface board that you could click, and that would then, of course, force you outside of the app into a normal browser. And that was like a complete experiment, of course. We had no idea how good conversion rates would be. And we ran some tracking on it, and actually there has been rather good conversions there, mostly due to the fact, I think, that the users that used the app, they were mostly pretty much hardcore fans. So they would want to go there anyways. So it's hard to tell if those numbers are really as good as they seem to be. But we kind of expected that nothing would happen, and a good amount of users actually clicked on those buttons repeatedly. So that was a nice surprise. So maybe something that can be experimented with further, as it worked reasonably well. This pretty much concludes it. So you guys still have some time to ask some questions. So thanks for listening, and please go ahead if everybody wants to know some more insights. Nobody? Then thanks for your time. We are actually hiring, so if anybody's interesting, let me know. And thanks for coming. Have a nice afternoon.